So now that we have the inverter slash NOR gate and our OR gate, I wanted to make the AND gate. I guess this is probably easier to turn into an AND gate, where really we just need to change the configuration of the transistors. Because right now, the transistors are tied together. So once any of their bases are given a high input, it will allow the output to go through to ground. So really what we need to do now is make a version of this. I don't want to change this one. I want to keep this as an OR gate. We need to make a version of this where the transistors, I guess, are in series, not like in this parallel type configuration where both need to be pressed, basically opening two switches. So really they're just switches. It's kind of a reminder to myself. These are really just, I guess, like fancy switches. So we can do that. I'm going to put these aside, and then I don't think I have any more small breadboards, unfortunately. I have like this, so they're a lot bigger. So he's kind of like a little spaceship. So if we model our OR gate, I'm gonna get a resistor out. I'm gonna trim his little legs and put it right near the top. This is row 5. Perfect. So this is not our input, sorry, this is our this power. I guess it's gonna go to a button. Shall we dare to try these little guys again? The revolters. When we press a button, it's going to power up. So I'm gonna use this orange guy. So it's a little long, but I think it works for now. So we press a button, and it should power up a transistor, the base. It should open the base so that, or it should activate the base so that the signal on the collector like can go up and out to the emitter, which needs to go into another transistor, I think, like in series, where transistor A collects the signal, and then when we energize the base, it will emit it to the second transistor. And then when we open this base, it will allow it to go out to ground. I think that works. So we'll have a button, a separate button for this base. So we open this base, the energy flows to transistor B, but it's still stuck until we press this button too, thereby making the AND, I guess, attribute or configuration. So I need another button, and I'm going to, I guess I need a separate input for that too. Maybe I should do it similar to how, yeah, I'm gonna do it similar to how I have the OR gate. So I'm gonna have my buttons here, and then the other button. Yeah, this probably makes more sense. So other button here. So I have 2 more resistors that are trimmed. These are 1Ks. I'm gonna put them in. So this goes positive to our button so that they can activate the bases. All right, and then the other one will go in. Cool. All right, so these guys get power here, and then they'll output it on these other dots. So here to the base and here to this base. So I need to just jump these lines over to go into their bases, these two. See what color can do that easily. Well, this orange one now is obsolete, at least for now. So I need a small little dude, maybe a gray guy, gray. Or an orange. No, gray. Okay, here's a gray. I feel like I use the gray ones a lot. So here's gray, and here's our output line, and it goes into the base. So, this is so hard to do sometimes. Okay, so this button is going into that base, and then I need another one to go into that base. This is A, we could say. This guy's getting bent up. Why don't you be like your brother? Just go easy. All right. So we have power going into the buttons. We click the buttons, and it goes into their bases. Now all we really need to do is give power to the collector, right? So I need another resistor. Man, I'm gonna go through these resistors pretty quick. So I'm gonna cut this guy. And cut. Okay. And then this is gonna be for the transistors. Okay. So we pretty much, oh wait, I could have used this guy. He's not doing anything right now. So power going into our transistor A, the collector, but he gets stuck in the base until this button is pressed. Then he comes, when it's pressed, the collector is able to send the, I was gonna say data, but like the power out of the emitter into collector B, but he gets stuck until this button is pressed. And then once we press this button, that's able to go out. And so now we need a ground so that they can all go home and be happy together. So, let's see. 15 is our row. Get in there. Man. By the end of this, I'm going to be good at putting wires in holes. Who else wants to try? Here's a green one, which is way too long, but whatever. Come on, green guy. Man. Okay, there we go. So, does this work? I'm not sure. But resistor, oh wait, I don't have an output. Damn it. Like I don't have a signal. So I need to put an LED in here. LED. Here's another LED. Okay. Long side is positive. So long side positive goes into the emitter. And I guess it could just stretch over. Yeah. Don't even need a wire. Okay. So power goes in to transistor A, but he's stuck until this button's pressed. When it's pressed, he goes to transistor B, but he's stuck until this button's pressed. And when it's pressed, it goes to LED and goes to ground. I think this works. I need more cables to connect the power. I'm just going to do one quick check to make sure that all my power from positive is resisted, but it is. I'm really worried about blowing something up. Or frying something is probably a better word. All right, so power goes in and negative goes in. So now we have nothing happening. But why not? Oh, I don't have power on this side. Damn it. All right, so we need to do that thing again where we transfer power over. Maybe I can do it over here. And maybe I can just bend it around like the other one. That's kind of messy. Okay, so this is our positive reaching over here, and then our negative. And, hey, can go in. Oh wait, I don't need negative, I only need positive. Okay, this works. This is not working right. Yeah, because all my ground is on this side, right? But so I just need. Okay, let's try that. So I'm gonna put power in again. When I press both, it's definitely bright and looks good. But when I press this guy, nothing happens. When I press this guy, though, he kind of turns on. What the heck? But he's dim. Because this is output. I could send this somewhere else, but this is not an effective AND gate. I'm gonna. All right, I'm gonna flip it around. I'm gonna do what I did for the OR gate first. So I'm gonna move this guy over just a wee bit. And then I'm gonna put the LED first. I want to make sure that the current going through him can only find a way to ground. I think, yeah, maybe that's my mistake. Yeah, his current, I guess because the current from the buttons is still going out of the emitter to ground. It's still illuminating the light over here. So that means that now we need another ground connection. So now I can use this green guy. So funny enough, he is and be used. So this is our output. No, it's not our output because we get like a false positive. Damn. I think I'm running into an issue right here, but let's put this in first. Dude, can you please just go inside the little hole? Okay. Whee! Okay, here he goes. There you go. All right, so let's plug in power again. Positive, negative. Individually, nothing happens. Both, nothing happens. What the heck? Oh, my LED's in the wrong slot. The negative. I need to know the names. I think one is like an anode and a cathode. But all right. So now he's in. Oh, so let's see. Yeah. So this works. This is an AND gate. However, very similar to this guy in the beginning, he had this LED as the indicator. But now this guy is the indicator. Now he's an output. I can't call him an output because I don't know how to use that. But this I can use, and he works. But when I tried to do this in this AND gate, it failed because it basically became just a switch on this button. This one did nothing. So that's a problem because how do I use this? You know? Like, how is this useful other than explaining how an AND gate works? But it doesn't help me if I can't send this off anywhere because this cable right now. Oh, you know what I should do? I should do what we did with the OR gate. Just add another LED instead of this cable. I'm gonna just keep it as an LED. Here's this. Whee. And he goes in. I should probably trim these two. I don't like their little legs sticking up so high. All right, let's plug this in again. And yeah, see, this is a problem. And this actually breaks my other dude now. Doesn't even light up anymore. Similar to the OR gate. I'm guessing there's just not enough voltage for both of them. So I don't know what to do. I think I'm going to... So, technically, it works, right? I'm just kind of thinking down the line, but technically it works. Technically, this is an AND gate. This is an AND gate. Right? Both need to be pressed and it turns on. All right. So I'm going to take that win. I'm going to take it. And now let's try a NAND gate.